Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us across the great arc of existence itself. We'll drift from the ticking pulse of our own hearts through the turning of the earth to the fading light of the last stars and into the long, soft silence that may one day follow the end of time. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these gentle explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always a quiet joy to see all the places we gather from, each of us in our own small corner of the clock. Now, dim the lights if you'd like, or turn on a fan for a soft background hum, and let's begin our slow walk into the story of time, its beginnings, its rhythms, and perhaps its end. Time is all around you. You can feel it in the rhythm of your breathing, in the pulse beneath your wrist, in the faint flicker of light from the window that tells you another second has passed. Even now, somewhere outside, the planet is turning, carrying every city, every ocean, and every sleeping mind with it. The world itself is a kind of heartbeat, steady, ancient and endlessly patient. Long before anyone owned a clock, people read time from the world itself. The rising and setting of the sun, the slow dance of stars across the night sky, the soft changes in the wind before the rain. Time wasn't something to count, it was something to feel. It lived in the glow of dawn, the stretch of shadows at dusk, the hush of night when crickets began their steady chorus. Every part of nature moved to its own rhythm, and together they formed the music of the world's great cycle. When you glance at a watch or a phone, you're really borrowing from a much older rhythm. The length of a day is not a number invented by us. It's the time the Earth takes to turn once beneath the sun. Though we call it 24 hours, it's actually a little less than that by the star's quiet standard, about 23 hours and 56 minutes. But the world does not turn perfectly. The moon tugs gently at our oceans, and the oceans pull back, slowing the Earth's spin. Our planet's heartbeat is gradually lengthening. In the age of the dinosaurs, there were about 370 days in a year, shorter days, quicker sunsets, faster nights. Now we have fewer, longer days. Every so often, we add a leap second to our clocks to keep pace with a planet that refuses to spin at quite the same speed it once did. It's a small adjustment, just 1 second, but it's a reminder. Even time, when tied to the turning of a world, is alive. You could think of Earth as an old friend who breathes a little slower with each passing age. Millions of years from now, a single day here will last a few moments longer. You and I won't be here to count them, but the planet will keep turning, slower and slower, as if savouring each breath. And while the world keeps time with its spin, we keep time with our bodies. Our eyes send messages to the brain when the light begins to fade, and in response the pineal gland releases a gentle chemical, melatonin, that tells the body it's time to rest. In the morning, sunlight touches your eyelids and stops that flow, raising your blood pressure, your body temperature, and your alertness. You rise not because of an alarm, but because the Earth has turned you toward the light again. The sun's rhythm becomes your rhythm. Your cells keep the beat. Inside your chest, your heart marks its own seconds, about 70 beats for each passing minute. A lifetime is made of billions of these tiny pulses. If you were to stretch all your heartbeats end to end, they would measure the length of your existence more honestly than any calendar. And yet, even as we live within these small circles of time, our minds reach outward into larger ones. We build machines that measure the ages of rocks, the flicker of distant stars, the decay of ancient atoms. Every clock we've ever made, no matter how precise, is a reflection of the same impulse, to hold on to the passing moment, to tame what always slips away. Modern science has shown us just how brief our moment is. The average human life today lasts around 70 years, a gift compared to the 20 years of our Stone Age ancestors, but still nothing against the Earth's age of 4.5 billion years, or the universe's age of nearly 14 billion. On the grand scale, we're a breath in the dark, a flash between two eternities, and yet within that flash, we have learned to follow the trail of time itself. We've learned that the Earth's gentle spin, the moon's pull, and the stars' distant shimmer all belong to the same story, a story written in cycles. We wake and sleep. The planet turns and tilts, the stars burn and fade. In all of it there is motion, rhythm, and change. That is time. Not a ruler or a ticking hand, but the quiet agreement that everything moves and that nothing stays still for long. As we drift further into the story, we'll leave the small clocks behind, the watches, the calendars, even the beating of our own hearts, and listen to the longer rhythms, the ones measured not in hours but in ages. Because to understand when time might end, we must first feel how it began, as a pulse, as a pattern, as a soft turning in the dark. Imagine standing on a beach at dawn. The sand is cool, the air still heavy with the night's quiet, and the first light of morning glides across the horizon like a slow breath. You might think the sun is rising, but in truth it's you who are moving. The planet is spinning eastward, carrying you toward the light. Every sunrise is a reminder that you're living on something that turns in its sleep, endlessly, gently, never quite in the same rhythm twice. The Earth's rotation began long before life existed, before oceans or clouds or the idea of a day. When the young planet was still molten and wild, a storm of dust and rock swirled around the newborn sun. Pieces collided, merged, and spun, and from that ancient violence, momentum was born. That momentum became rotation. Our world has been turning ever since, slowing only slightly, like a top that refuses to fall. If you could see the Earth from space, you'd notice its spin isn't perfectly smooth. It tilts, wobbles, leans forward, then rights itself. These small movements happen over thousands of years, as if the planet itself were adjusting its balance from age to age. Scientists call these slow sways cycles, but you might think of them as the Earth's shifting posture in its long sleep. Each rotation takes a little less than a full 24 hours, by the sun's measure, 23 hours and 56 minutes, though by the stars, even a touch less. That's the tempo of our planet's song, the rhythm behind every heartbeat and clock tick you've ever known. But the melody is changing, ever so slightly. The moon's gravity pulls on our oceans, raising and lowering the tides. As water moves, it drags gently against the seafloor, stealing a fragment of Earth's momentum. Over millions of years, that resistance adds up. The Earth slows down, our days lengthen, our nights grow just a breath longer. If we could travel backward, far enough to walk alongside a sauropod grazing in a fern forest, we'd find the days were shorter. A year back then held 370 sunrises, not 365. That extra handful of dawns wasn't a gift from the heavens. It was the world spinning a little faster, its dance still young and restless. Now, billions of years later, the same dance continues but at a slower tempo. It's as though the Earth has aged, grown wiser, and decided there's no need to hurry. Every so often, humans add a leap second to our clocks, a tiny adjustment, a nod of respect to the planet's unhurried drift. It happens about once every year and a half. In those moments, the digital numbers we trust so much pause for just a heartbeat. For 1 second, time itself stands still. You could blink and miss it, yet that small gesture keeps us in rhythm with the planet beneath our feet. This rotation shapes everything we experience, from the soft rhythm of days and nights to the moods of our atmosphere. The winds you feel brushing your skin are stirred, in part, by this turning. Oceans form great loops of current guided by the spin. Even the invisible paths of migrating birds and drifting seeds are drawn along invisible lines created by a moving world. Our ancestors sensed this motion long before they could prove it. They watched the sun glide across the sky, the stars wheel in great circles, the seasons flow one into another. They saw time not as a line, but as a circle, something that always returned. The world would warm, then cool. Leaves would fall, then bloom again. They built monuments to follow this cycle, stones aligned with sunrise and sunset, spirals carved into caves to mark the endless return of the light. To them, the planet's turn wasn't just physics, it was faith. When we finally learned the truth that the Earth moves and not the heavens, it didn't diminish the wonder, it deepened it. Copernicus and Galileo helped us see that the sky isn't spinning around us. We are the ones turning, together, on a tiny sphere in an ocean of space. The constellations that seem to drift each night are really our own changing point of view. The heavens don't revolve, we do. Every rotation, every tilt, every wobble is part of a larger balance. The Earth leans at just the right angle, about 23.5 degrees, enough to create seasons, enough to breathe variety into our world. If it stood perfectly upright, we might never know spring or autumn. Life might have been stillborn in endless sameness. But our world is tilted, and in that tilt lies beauty. You can feel that angle each time you step outside in a different season. The smell of new grass after the first rain of spring. The long golden slant of late afternoon in autumn. The way shadows stretch in winter as if time itself was slowing to rest. These are not random accidents. They are signatures of the Earth's turning, signs of a clock so vast and patient that it carries the lives of forests, oceans, and civilizations within its rhythm. It's strange, isn't it? We spend our days trying to keep time, setting alarms, planning schedules, counting minutes, when all along time has been keeping us. Every breath, every movement of water and cloud, every drift of dust in sunlight is tied to the turning of this globe. We don't just live in time, we are carried by it, like leaves, in a slow and endless current. And yet, this spinning cannot last forever. The same forces that once set the Earth in motion are still at work, pulling, dragging, reshaping. Millions of years from now, our planet will turn more slowly still, the moon will drift farther away, the dance between them, delicate and ancient, will change its rhythm once more. For now, though, the world still turns, one soft rotation at a time. The continents move quietly through space, the oceans breathe in rhythm with the stars, and you, without feeling it, spin with them, completing one more circle through the light and back into the dark. As we follow this turning further, our quiet exploration now turns to the larger cycles hidden within the Earth itself, slow movements of wind and water and stone that stretch beyond the span of human memory, revealing that time on this planet flows not only in days and nights, but in ages. Every morning, long before your thoughts begin to stir, your body has already started speaking to the light. There's a silent exchange between the world outside your window and the tiny universe within your cells, the pale glow that seeps through the curtains, even before sunrise slips past your eyelids and reaches the retinas at the back of your eyes. From there, a message travels deep into the brain to a small cluster of nerve cells that keep the master clock of your body. This clock isn't made of gears or batteries, but of chemistry and rhythm. It listens to light, marking the difference between morning and evening, between alertness and rest. When daylight fades, that tiny region in the brain begins to whisper to the pineal gland, a pea-sized organ nestled in the dark centre of your head. The pineal releases a gentle chemical messenger, melatonin, like a slow trickle of calm water through the bloodstream. Your heart rate softens, your blood pressure falls. The body begins to cool itself by a fraction of a degree. Every system prepares quietly for sleep. It's as if your body knows the Earth has turned you away from the sun. You don't have to think about it. The planet and your pulse are already in conversation. You might close your eyes on a distant world, but you wake again because of the light from a nearby star. This exchange has been going on since the first single-celled creatures floated in the ancient seas. They too reacted to sunlight, opening and closing, feeding and resting in rhythm with day and night. Over billions of years, those early organisms wrote this pattern into their descendants, and it has reached all the way to us. Every heartbeat, every breath, every flicker of energy in the body carries traces of that inheritance. We are made of matter that learned to tell time. If you could shrink yourself down to the size of a cell, you'd find thousands of tiny clocks ticking in harmony with the larger one in your brain. They keep track of hours and minutes without ever seeing a clock face. They know when to release hormones, when to repair tissues, when to build energy from the food you eat. These cellular rhythms are so finely tuned that even a few hours of light or darkness at the wrong moment can leave the body confused. That's why jet lag feels like drifting through fog. Your inner clocks and the planet's rotation briefly fall out of sync, but when they align, the world feels right. Morning light signals your brain to stop producing melatonin. Your blood vessels tighten, raising your blood pressure just enough to get you moving. Your body temperature rises slightly, your metabolism stirs, and you open your eyes. The simple act of standing in sunlight is the oldest conversation we've ever had. The warmth of a star translated into motion and thought. In that sense, the sun doesn't just give us light and heat, it gives us rhythm. It winds the clocks in our cells every morning, setting them to the same pulse that drives weather, tides, and the turning of the earth. When you yawn at night or feel suddenly awake at dawn, that's not just fatigue or habit. It's a dialogue as old as life itself, carried out through molecules and memory. If we follow the thread a little further, we find that even our moods trace these invisible cycles. The body's clock influences the ebb and flow of hormones that colour our emotions. Cortisol rises in the morning like sunlight for the mind, sharpening focus. By nightfall, serotonin gently yields to melatonin, letting the mind grow quiet. These waves of chemistry follow the same tempo as the day outside, reminding us that balance isn't found in constancy, but in alternation, in the gentle swing between activity and rest, between brightness and shadow. You might notice how, in winter, the lack of sunlight makes the body feel heavier, slower. The same happens to animals that hibernate or trees that drop their leaves. Time changes shape depending on the light. A single day in summer feels longer, more generous than a day in the cold, dim months. In truth, the hours haven't changed, but the body's conversation with the sun has softened. The light writes a slower script. Imagine this rhythm playing out across every living being on Earth. The collective heartbeat of forests opening to morning, coral reefs blooming by day and resting by night, flocks of birds using the angle of sunlight to find their way across oceans. Life on Earth is not just alive in time, it's written by it. Even the flowers that close at dusk and open at dawn keep their rhythm when placed in total darkness. Somewhere inside, they remember the sky. These cycles are more than routine, they are harmony. Every creature, from a drifting plankton to a human mind, is part of a vast planetary symphony tuned by the sun's slow pulse. The earth spins, the light changes, and life listens. The rhythm is so steady that we hardly notice it until we're out of step. Then we feel it as restlessness, sleeplessness, confusion. But when we move with it, we sense something deeper, a calm awareness that time is not an enemy to fight, but a companion to trust. There's a quiet comfort in knowing that no matter how busy a day becomes, you're never truly separate from this rhythm. The same sunrise that touches mountaintops reaches the corner of your room. The same sunset that falls over oceans closes your eyes. Light travels 93 million miles to tell your body that another day has begun. Perhaps that's why the fading of sunlight feels so peaceful. The colours deepen, the shadows grow long, and the body begins its descent into rest. The sun sets for the world, but also for you, and when it rises again, you will rise with it, not by will, but by design, as part of the oldest conversation the Earth and its life have ever known. As our path drifts further into the story, we begin to sense that the rhythm of the sun is not alone. Beneath the pulse of day and night lie slower patterns, the slow tilts of the Earth, the long breath of oceans and ice, the subtle weaving of climate and carbon. These are the planet's older conversations with time, unfolding across ages rather than days. If you could listen closely to the Earth, not to the wind or the waves, but to the rhythm beneath them, you might hear something like breathing, a slow, steady inhale and exhale, stretched across centuries. The tides are the shallowest notes of that song moving in and out each day. The weather hums in months and seasons. But deep below, in the slow pulse of ice and stone and ocean, the planet breathes in cycles of its own. The warmth of the sun begins the first movement. Only a tiny fraction of its energy, about 1/1000th of the total light it gives off, ever reaches our world. Most of it races past us into the black sea of space. But that small gift of light is enough to stir the oceans, feed the winds, and sustain every living thing you've ever known. It is light that keeps the world's clock turning, winding the invisible springs of air, water, and life. When sunlight strikes the equator, it warms the air and lifts it skyward. That air drifts toward the poles, cools and falls again, setting in motion vast, unseen rivers in the sky. These currents of air weave around the planet, creating seasons, storms, and climates. They are like the planet's breath, gentle and endless. Meanwhile, the oceans, too, are restless. Great loops of current move through them, like the slow turning of the Earth's heartbeat. Warm water travels across the surface of the seas and then sinks into the deep, where it can take centuries to return. A drop of water that leaves the coast of one continent might not surface again until another civilization has risen and fallen. In this way, the ocean keeps a memory of the world's changes, carrying heat and carbon and whispers of ancient rain. The tilt of the Earth shapes these patterns. Our world does not stand straight. It leans, just slightly, about a quarter of the way between vertical and horizontal. That tilt gives us our seasons. As the planet orbits the sun, sometimes one hemisphere turns toward the light and sometimes away. In summer, the days lengthen and light lingers. In winter, the light retreats and cold gathers in its absence. The rhythm repeats, steady as a pendulum, painting our years with change. But the Earth's lean is not fixed. Over tens of thousands of years it sways and wobbles, like a spinning top that slowly changes its angle. These long, graceful motions are what scientists call Milankovitch cycles, though the name matters less than what they mean. They are the planet's deeper breaths. Every 20 or 40,000 years the tilt shifts, and with it, the balance of light between the poles and the equator. Ice thickens, then melts. Oceans rise and fall. Deserts bloom, then fade. The pattern moves too slowly for any one lifetime to feel, yet all of history dances to it. These wobbles, combined with the slow change of the Earth's orbit, have been known to summon and dismiss entire ice ages. When the northern lands tilt too far from the sun, glaciers creep down from the poles, burying valleys in frozen silence. Thousands of years later, as the tilt eases back, the ice sighs and retreats, releasing rivers and forests again. You could say that the planet exhales warmth after a long frozen breath. There is another rhythm, slower still, the carbon cycle. The air you breathe contains tiny traces of carbon dioxide, the same gas that once warmed the ancient Earth. Every time a leaf unfurls, it draws in that carbon, locking it away within the green. When the leaf falls, it releases it again. Some of that carbon sinks into soil or drifts into the ocean, settling on the seafloor as a grain of dust or a shell fragment. There it waits, sometimes for millions of years, until the shifting of the Earth's crust or a volcanic eruption returns it to the air. What you exhale tonight may one day feed a tree, or rise again as smoke from a mountain that hasn't yet formed. The planet remembers everything. Every molecule of air, every drop of water, every grain of sand has been here since before your first ancestor walked the Earth. They only move between shapes. Air becomes rock, rock becomes ocean, ocean becomes rain. This slow dance of transformation is time itself written into matter. It's easy to think of time as a straight path, a forward arrow marked by dates and numbers, but here, time is a circle. The ocean moves in centuries, the ice comes and goes in cycles of tens of millennia. Even the continents themselves drift apart and come together again over hundreds of millions of years. If you were to watch the Earth from afar, speeding up the film of its life, you'd see it pulsing gently, changing colour, inhaling light and exhaling shadow. You would see a planet that does not simply endure time, but creates it. This idea can be comforting. The world beneath your feet is not fragile or fleeting. It is an old musician, playing a melody far longer than any human song. Every storm, every snowfall, every rising tide is part of that ancient composition. We're just a brief note in the middle of its endless refrain. Even our climate, with all its complexities and crises, is a continuation of this rhythm, one that we have joined, not one we control. Our actions may quicken or disrupt it, but the underlying pulse remains slow and deliberate. The planet will find new equilibriums long after our calendars and machines are gone. And yet, knowing this doesn't diminish our part in the story. It deepens it. When you feel the wind on your face or hear the sound of rain against glass, you are sensing something that began before you were born and will continue long after you're gone. You're part of the breath of a living planet, drawn in and exhaled, like all who came before. From here, the story opens into the wider cosmos. If the Earth's rhythms stretch across millennia, the universe itself moves in epochs so vast they make even the ice ages seem like seconds. To glimpse those larger patterns, we'll lift our gaze from the horizon and look toward the stars, the slow heartbeat of the cosmos itself. Close your eyes for a moment and imagine the universe before there were any stars, before light itself had learned to shine. There was no night or day, no galaxies wheeling through space, only a vast hot sea of energy and particles, a kind of cosmic fog. If you could have stood there would have been nothing to see, yet everything that would ever exist was already there, pressed together in a single restless breath. That beginning is often called the Big Bang, though the name can be misleading. It wasn't a sound, nor an explosion bursting into empty space. It was space itself expanding, stretching, swelling, carrying everything outward all at once. You might think of it as dough rising in every direction, where every raisin moves away from every other, not because the raisins travel through space, but because the dough itself grows between them. That first expansion marked the start of time as we know it. Before that, there was no ticking clock, no before for anything to happen in. As the universe expanded, it began to cool. In its earliest instance, it was so dense that matter and energy were nearly the same thing, mingled together in a blinding plasma of particles. Tiny sparks called quarks paired and separated in an endless dance, forming the first protons and neutrons, the seeds of atoms. But these first pieces could not yet settle. The universe was still too bright, too wild. A few heartbeats later, though those heartbeats stretched across hundreds of thousands of our years, atoms began to take shape. Hydrogen appeared first, the simplest of all elements, joined later by helium. They drifted through the expanding darkness, tiny building blocks waiting for gravity's touch. Imagine them as dust on a wind that had no edge. The light from those early days still travels through the universe today, stretched so thin by the expansion that it now hums in the microwave range, a faint echo known as the cosmic background. It fills every direction of the sky equally, like the afterglow of a fire that once filled everything. If your eyes could see that kind of light, the night would never be completely dark. For hundreds of millions of years, the universe drifted in this shadowy calm. No stars burned yet. Space was a soft darkness, thick with invisible gas. This was what scientists call the cosmic dark ages, though that phrase doesn't quite capture its beauty. It was more like a quiet lullaby before the first dawn, a pause between creation and illumination. Then gravity began to gather the scattered matter. Slowly, delicately, it pulled hydrogen and helium together into clouds, and those clouds grew dense in certain places, clumping and swirling until their centers grew hot. When the temperature reached a few million degrees, atoms began to fuse, the moment when light and warmth burst forth. The first stars were born. They were enormous, much larger than the ones we see today, because the early universe was pure and simple, made mostly of hydrogen. These first giants lived fast and died violently. Their lifetimes were measured not in billions, but in mere millions of years, short lives on a cosmic scale. When they died, they exploded, scattering the heavier elements they had created: carbon, oxygen, iron. These were the ingredients for everything that would come after: planets, oceans, air, and eventually life. If you could have watched from some distant vantage point, you would have seen the universe bloom like a field of fireflies, small sparks appearing everywhere, brightening the darkness for the first time. Galaxies began to form from these gatherings of stars, spinning slowly into the shapes we know today. Gravity continued to weave its quiet spell, drawing stars together into great islands of light, each one a family of suns bound by their mutual pull. Among these newly kindled lights, there were already signs of what was to come. Some stars collapsed inward rather than exploding outward, forming black holes, the strange, silent cause where gravity reigned supreme. These black holes, though tiny at first, began to feed, growing larger, anchoring the hearts of galaxies. Even then, the universe was building its future seeds of mystery. Back on a smaller scale, the ordinary matter, the atoms of hydrogen and helium, began to collect in rings and disks around newborn stars. Within those spinning disks, tiny grains of dust collided and stuck, forming pebbles, then boulders, and eventually planets. One day, far in the future, on one of those planets, beings would look back and try to imagine this beginning. They would give names to epochs, craft theories, and wonder if there had ever been a moment before time. From our place billions of years later, it's hard to grasp just how fast and how vast those changes were. But the important thing to know is that everything, the stars, the galaxies, the air in your lungs, descends from that first surge of energy and expansion. We are quite literally made from the cooling of light. The age of stars had begun, and with it the rhythm of cosmic time as we understand it. The universe had found its heartbeat, the cycle of creation and destruction, of fusion and collapse, of light emerging and fading again. Each pulse stretched across millions, even billions of years. To a human being that might seem eternal, but even this age of brilliance would have its end. For now though, imagine the stillness between those early lights. The dark fabric of space spread wider and wider, sprinkled with new stars like the first sparks of a distant campfire. That faint shimmer, that growing field of light, is the origin of everything we call beauty. The glow of sunsets, the fire of thought, the warmth of a hand. All of it began in that first dawn when the universe woke up and learned to shine. As we drift further into the story, we'll follow those lights into the ages that came after, the long balance between gravity and energy that shaped the stars, the galaxies, and eventually the home that orbits beneath your feet. Every star you see in the night sky is a quiet miracle of balance. Each one is born from the same ancient tension that threads through the whole universe, the pull of gravity drawing everything inward, and the push of fire trying to break free. The result is not conflict but equilibrium, like the steady breath between heartbeat and rest. Long ago, before there were stars, space was filled only with drifting clouds of hydrogen and helium, simple, invisible gases left over from the universe's first cooling. Gravity began to gather those clouds, coaxing them closer, pulling until their centres grew hot and dense. In those hidden hearts, the atoms started to fuse. It was a kind of alchemy, a transformation where the tiniest particles combined and released light. That light fought against the crushing weight of gravity, and the two forces found a temporary peace. In that peace, a star was born. It's easy to imagine stars as distant, lifeless spheres of gas, but they are more like living things than you might think. They grow, they age, and eventually they die. At their core, the same process that gives them life also counts down their days. The hydrogen at their centre, the simplest and most abundant element, is their food. As they fuse it into helium, they shine, but with every pulse of light they send across space, a little of that fuel is spent. Every sunrise on every planet is the echo of a star's slow expenditure of itself. Inside a star, fusion is the art of turning light into structure. It's a chain reaction that begins with heat and ends with order. In the simplest terms, when two atoms meet under immense pressure, they merge, and a fraction of their mass transforms into energy. That energy pushes outward, holding the star open against its own weight. But stars live by the same rule everything else in the universe follows. Nothing can burn forever. Massive stars live fast and die young. The larger the star, the stronger the pull of gravity inside it, and the more fiercely it must burn to keep from collapsing. These stars blaze like cosmic bonfires, spending their energy in a few short millions of years. Small stars, on the other hand, those tiny red embers scattered across the galaxy, burn gently, conserving their fuel so carefully that they may glow for 100 trillion years or more. If the universe had a heartbeat, these stars would be its slow, enduring rhythm. Entropy, the quiet law that governs all change, ensures that this balance cannot last forever. Entropy doesn't destroy, it diffuses. It's the gradual spreading of energy, the gentle unravelling of order. In a star, entropy manifests as the slow cooling of its fire, the thinning of its fuel. Everything bright spends itself. The warmth we feel from sunlight, the glitter of starlight across the sea, these are gifts offered at a cost. The universe gives us brilliance, but only by allowing its brightest lights to fade. For now, our sun sits comfortably in the middle of its long life. Its gravity and its energy are matched, holding it steady in a graceful truce. It breathes light outward in every direction, a steady golden pulse that has nurtured our world for billions of years. It is neither young nor old, just in that peaceful middle age when a star's fire burns clean and calm. You might say it's in the prime of its existence, a balance so perfect that it feels eternal. But nothing, not even harmony, lasts forever. Far away, in the cold reaches of the galaxy, there are stars of every kind. Giants that flare blue and fade white, and faint red dwarfs that barely glow. Each of them carries within its core a version of the same story, gravity trying to pull inward and light pushing outward. It's the universe's oldest conversation, and every flicker of starlight you see tonight is one sentence in that dialogue. When you look up at the night sky, the stars seem still, but you're seeing them in motion, in all stages of their lives. Some have just begun to shine, gathering gas in their infancy. Others are nearing their end, their light softened by age. The heavens are not frozen, they're a field of time, each star a point on a vast, unfolding timeline. You're seeing the past as it streams toward you, light that left its source before your ancestors took their first breath. This slow exchange of energy between gravity and fire shapes not only the stars, but everything around them. Planets form in the leftover dust that circles them, gathering warmth and light from their parent suns. Moons find their paths. Oceans shimmer. On at least one small world, life learns to open its eyes and gaze back at the source of its light. If you've ever sat beside a campfire, you've felt the same principle in miniature. The logs collapse inward as the flames rise outward. For a while, the two forces meet in balance until the wood turns to ash and the light softens to embers. A star is no different, only greater and slower. The universe itself is the hearth, and the stars are its flames burning through cosmic night. The beauty of this balance is that it does not end abruptly. When a star's fuel begins to run low, its rhythm changes. Gravity starts to tighten its hold. The fire pushes back with one last effort, swelling and brightening before the final fade. For some stars, that end comes with an explosion, a supernova so bright that for a brief moment it can outshine an entire galaxy. For others, like our sun, the ending will be quieter, a slow expansion into a giant shell of light. Everything in nature, from a heartbeat to a supernova, follows this same law of rhythm and release. To exist is to balance energy and gravity, brightness and stillness, creation and decay. The stars teach us that equilibrium is not stillness. It's the act of staying in motion just enough to remain whole. As we drift further into this story, our attention turns toward one particular star, the one that warms our oceans, paints our mornings in gold, and marks the passage of our days. It too lives within this balance, burning with the same quiet determination as all its kin, but even the most steadfast light has its twilight. The path ahead will lead us gently into the story of our sun's own aging, and the calm, luminous farewell it will one day give to its world. For now, the sun is a picture of calm, an endless flame that neither flickers nor fades, steady enough to anchor our world in warmth and rhythm. Every sunrise is a reassurance that this ordinary star, hovering in its quiet balance, will rise again tomorrow. It burns hydrogen into helium deep within its core, turning matter into light and sending that light out across 93 million miles of space to spill gently onto oceans, trees, and the faces of those who look up. That glow is so constant that we forget it is not permanent. Inside, the sun is always in motion. Hot gas flows like liquid, currents of plasma twist and rise, magnetic fields dance and shift. The sun breathes in loops of fire, slow, rhythmic pulses that take years to complete. Every flicker on its surface, every wave of heat, is part of a vast, steady heartbeat. It has been doing this for nearly 5 billion years. In that time, continents have formed, life has appeared, and humans have learned to measure its days. Yet to the sun itself, all of this would feel like a single morning's work. But nothing in the universe stands still. Within the heart of the sun, hydrogen, the simplest and most plentiful of elements, is being steadily transformed into helium. Each atom that fuses releases a whisper of light, and that light is what holds gravity at bay. For now, there is enough hydrogen to keep this balance for billions of years to come. But slowly, quietly, the supply is running down. The sun's core will grow richer in helium, heavier and more compact. The outer layers will respond with warmth, expanding slightly, glowing a little brighter each century. Far in the future, when the sun is twice as old as it is now, this slow change will begin to matter. The Earth's oceans will shimmer away under a sky that grows too bright. The seas will shrink into salt flats. Clouds will thin. The air will lose its moisture, and blue will fade from the planet's skin. What was once the colour of life will turn to pale gold and dust. It won't happen quickly. It will take hundreds of millions of years, more time than every human generation combined. But in the grand rhythm of stars, this is simply one more verse in a long song. As the sun ages, it will begin to swell. Its body, once tight and compact, will relax and balloon outward. The light will shift from gold to deep orange, as though the sun were becoming a perpetual sunset. This is the red giant phase, a time when gravity and heat trade places in their struggle. The outer layers will drift outward into space, thinning into great veils of glowing gas. The Earth, if it still orbits nearby, will not escape that reach. The sun will grow so vast that its edges brush the orbit where our planet moves, and friction from that touch will draw the Earth slowly inward. Over a long, quiet spiral, the planet will dissolve into light. It sounds like tragedy, but the truth is gentler. The sun will not devour the Earth in anger. It will simply expand beyond its limits, as all living things do in the final stage of life. What began as fusion's fire will end in luminous surrender. The sun's radiance will scatter its outer layers into space, forming delicate rings of light, like the petals of a dying flower glowing from within. These shells of gas will drift outward, and for a time the sun will appear as a soft lantern in the dark, surrounded by its own fading breath. At the centre of that lantern will remain a small white ember, the sun's core compressed into a sphere no larger than the Earth itself. Though shrunken, it will hold more mass than any mountain, more density than steel could bear. This white dwarf, as astronomers call it, will shine with the leftover heat of its long life, glowing faintly for billions of years. Gradually it will cool, dimming from white to red, and finally to black, a quiet, crystalline relic drifting through the emptiness. In that far, unimaginable future, another civilization somewhere might look toward the same patch of sky and see a faint spark where our sun once blazed. To them, it might be no different than any other star, ancient, unremarkable, but beautiful all the same. They might wonder if any worlds once circled that faint light, if there was ever a place where oceans moved to its rhythm and creatures warmed their hands by its glow. The story of our sun's future isn't about destruction, it's about transformation. The atoms that once made up the Earth will scatter into space, joining the raw material for new worlds. Somewhere, perhaps, another star will use that matter to build planets of its own. The cycle will continue, and though our world will vanish, its essence will remain woven into the universe. You could think of it this way. The sun is not dying. It is changing form, giving its energy back to the cosmos that once gave it birth. Its death will seed the next generation of stars, the way fallen leaves feed the soil. Every bright ending becomes the beginning of something new. There's a quiet comfort in this too. Even when the sun's light is gone, the memory of its warmth will remain, carried in the atoms of dust, in the glow of distant nebulae, and in every living being that once basked in its rays. The sunlight you feel on your skin today began its journey inside the sun thousands of years ago, travelling slowly through dense layers before escaping into space and falling gently upon the Earth. Each photon is a message from the past, a small promise that light endures. One day, that steady pulse will fade and our solar system will enter its twilight. But the universe doesn't end in silence. It continues to hum with the echoes of all that has ever burned. Our world will not end in darkness, but in radiance, dissolving into light that will wander forever. And as the story drifts forward, we'll follow that light outward, toward other stars, other endings, and the vast, glittering cycles of death and rebirth that fill the galaxy. Because what happens to our sun is not unique. It's the universal destiny of every flame that ever learned to shine. When a star reaches the end of its long, glowing life, the universe does not fall silent. It sighs, it releases what was gathered, scatters what was made, and begins again. The death of a star is not destruction, it's renewal written in fire. Across the great dark of the cosmos, endings and beginnings happen in the same breath. Some stars end gently, fading into small embers like our sun will one day do. Others choose a more spectacular farewell. The most massive among them spend their lives burning furiously, consuming their fuel in just a few million years, a blink in cosmic time. When their cores run out of the lightest elements, they turn to heavier ones, fusing carbon into oxygen, oxygen into silicon, and finally silicon into iron. And there, at iron, the story changes. Iron cannot be fused into anything that gives off energy. It's the stopping point, the still centre of the nuclear dance. When a star's heart fills with iron, the balance that kept it alive collapses. Gravity, patient and persistent, finally wins. The outer layers fall inward in a sudden rush, striking the core with such force that the rebound sends a shockwave through the star's body. For a moment shorter than a heartbeat, the star tears itself apart. To an observer far away, that moment is dazzling. The dying star explodes in a burst of light so bright that it can outshine an entire galaxy. The explosion is called a supernova, but that word barely captures the violence or the beauty of what's happening. The blast hurls matter into space at incredible speeds, seeding the universe with the heavy elements it forged in its heart. Every atom of gold, calcium or iron in your body was once part of such a storm. The iron in your blood, the calcium in your bones, the gold in a wedding ring, all of it was born inside a dying star carried outward in waves of radiant ash. It's strange to think that the universe recycles itself through such chaos. But this is how creation works on a cosmic scale. The debris of one generation becomes the foundation of the next. When those clouds of stellar dust drift through the galaxy, gravity begins to work its quiet spell once more. Slowly they gather and swirl, forming new stars, new planets, new possibilities. The universe never stops rebuilding itself. If you could float through one of these star-forming regions, it would not feel like emptiness. It would be a luminous fog filled with filaments of dust and gas glowing faintly where the light of newborn stars filters through. These nebulae, the nurseries of the cosmos, are where everything familiar was first imagined. The atoms that now form your eyes once drifted through such a place, cooled and quiet, waiting for the right gravity to bring them together. Not every star's end is so explosive. Some collapse inward under their own weight, compressing into unimaginable density. If a dying star is about the size of our sun, it becomes a white dwarf, a crystal sphere of packed matter that cools slowly over billions of years. But if the star was far larger to begin with, gravity pulls more tightly, squeezing it beyond all reason. Its core becomes a neutron star, an object so dense that a spoonful of it would weigh more than an entire mountain. And then there are those that go further still. When gravity overwhelms every other force, when nothing, not even light, can escape its pull, a black hole is born. It isn't a thing in the usual sense, but a place where the fabric of reality folds in on itself. Around it, the universe seems to fall inward, drawn toward a centre that has no surface. These strange objects are the ultimate expression of gravity's power, the quiet monuments left behind when creation consumes itself. Yet even here, in these final states, there's beauty. A supernova may destroy its star, but it also ignites a new era. The shockwave can trigger other clouds nearby to collapse, beginning another cycle of birth. The death of one star can be the spark for hundreds of others. In that way, the universe is like a forest that thrives on fire. The ashes feed the soil for the next generation of growth. Our own galaxy carries this rhythm everywhere. The Milky Way's arms shimmer with young stars formed from the remains of ancient ones. The delicate blues and golds you see in photographs of spiral galaxies are the signatures of this continuous rebirth. Every bright patch is a region where a star has died and a new one has begun to burn. If you look long enough, you start to see that the galaxy is alive, constantly remaking itself. This cosmic recycling connects us directly to everything that ever was. The atoms that once formed the heart of a massive star now sit within you, vibrating softly with warmth and life. The breath you take tonight might contain particles exhaled by some long-vanished sun. The boundaries between you and the cosmos are not as solid as they seem. They are threads in the same fabric, weaving endlessly through creation and decay. Even black holes, those symbols of finality, play a part in this balance. Their immense gravity helps sculpt galaxies, influencing how stars are born and how matter moves. They are not just ends, but also shapers of new beginnings. If you step outside on a clear night and tilt your head upward, every pinprick of light you see is both ancient and new. The star's light that reaches your eyes began its journey long before your species existed. Yet within that same light lies the promise of future worlds, because even as those stars burn away, others are forming from their remnants. Time, in this cosmic sense, isn't a straight line. It's a wheel turning endlessly, each spoke carrying life from fire to ash and back again. It's comforting to realize that death, even on the scale of stars, isn't truly an ending. It's transformation. Every sunrise on Earth, every living heartbeat, is powered by energy released from ancient deaths. Every atom in your body has seen the inside of a star. You're living proof that the universe remembers how to begin again. As our quiet exploration continues, we drift outward now to see this process on an even grander scale. Beyond the lives of individual stars, into the destinies of entire galaxies. For there comes a time when the universe itself begins to grow older, when the bright crowds of stars thin and the vast spiral arms begin their slow, graceful collapse into twilight. The Milky Way drifts through space like a great spiral of starlight, its arms curling gracefully, its heart glowing softly where clouds of gas and dust shimmer under the touch of newborn suns. From our place within one of those arms, we can never see the galaxy in full. We're too close to its light, like a bird trying to glimpse the shape of its own flock. And yet, we know its form through patience and mathematics, through the slow gathering of light from distant corners of the sky. What we've learned is both comforting and humbling. Our galaxy is not alone. It's one of billions, each following its own long rhythm through the universe. The Milky Way has a neighbour, a spiral of stars nearly its twin, called Andromeda. It shines faintly in the northern sky, so far away that its light has taken over 2 million years to reach us. When you look at it, you're seeing the past, light that began its journey before there were humans, before there were cities or words. But that distance is shrinking. Andromeda is moving toward us, drawn by the quiet insistence of gravity. One day, the two galaxies will meet. It won't be a crash, not in any way we might imagine. Space is mostly empty, and the stars within these galaxies are separated by vast stretches of nothingness. When they come together, they will pass through each other like clouds mingling in the sky. No stars will collide, but their gravity will twist and stretch the galaxies into long ribbons of light. It will be, in its own way, a slow and beautiful dance, one step taking millions of years. If there are beings alive to watch it then, perhaps standing on a surviving world orbiting some distant star, their night sky will be unrecognizable. The graceful band of the Milky Way will swell and ripple, its familiar arc distorted by new rivers of light. Andromeda's stars will appear to bloom like a second galaxy rising in the sky, until the two merge completely. It will look as if the heavens themselves have opened, filled with stars that were once impossibly far apart. As the galaxies intertwine, their central black holes, each millions of times the mass of a star, will circle one another in an invisible orbit. Slowly, over eons, they will draw closer, releasing waves of energy that ripple through the very fabric of space. When at last they meet, they will fuse into a single, larger black hole. anchoring the heart of the new galaxy that forms from the remains of both. This cosmic merging is not rare. Across the universe, galaxies are constantly encountering each other, pulled together by their mutual gravity. It's part of the grand rhythm of cosmic evolution. Young galaxies are like clusters of bright notes, colliding and blending into new harmonies. Their collisions can stir up clouds of gas, igniting fresh waves of star birth. Old galaxies merge to form larger, smoother shapes, glowing softly as they settle into stillness. The universe writes its history through these encounters, each collision a punctuation mark in a story that spans billions of years. You might imagine such an event as chaos, but in truth it's more like music. Gravity conducts the performance, moving stars along paths of elegance and grace. There's no violence here, only transformation. The stars that once spun apart will find new patterns, new orbits, new companions. Entire clusters may be flung into the dark outskirts, while others will settle closer to the new galactic core, forming a great luminous cloud. When the Milky Way and Andromeda finally combine, about 4 billion years from now, the result will likely be a large rounded galaxy, its spiral arms smoothed away by time and motion. Astronomers call this kind of shape an elliptical galaxy, but you might think of it as a puffball of ancient light, a quiet bloom at the end of a long cosmic dance. If there are still worlds with life then, those skies will be breathtaking. The stars will be closer, more numerous, and the night will glow like a soft sunrise that never fully fades. Even as the universe grows darker overall, there will be these local islands of brilliance, places where gravity has gathered the last embers together for one final performance. Our galaxy's fate, then, is not to vanish suddenly, but to change, to lose its delicate spiral shape and become something simpler, calmer, older. The same principle that guides the lives of stars applies to galaxies. 2. What burns bright eventually relaxes into stillness. The universe, it seems, prefers peace over eternity. Sometimes, late at night, it helps to remember that even the vastest collisions in existence unfold in silence. If you could stand outside of time and watch the Milky Way and Andromeda come together, you wouldn't hear a single sound. The light would move in slow motion. Clouds of dust would stretch like silk. The dance would last longer than the age of the Earth, and every step would be smooth. There's something deeply soothing in that. Even the universe changes without hurry. From here, our quiet journey follows the light outward again, beyond the merging of galaxies, to a time when this cosmic choreography begins to slow. The story that once felt full of brightness and birth will turn toward quietude. Gravity will weaken its grip, distances will grow, and the fabric of space itself will begin to stretch faster than light can follow. What began in the intimacy of collisions will end in separation, a universe that is learning, slowly, how to let go. If you look far enough into the night sky, you're also looking far back in time. Every glimmer of light carries a memory. The faintest galaxies we see today began their glow billions of years ago, when the cosmos was still young. And in that light hidden between the stars lies a subtle message. The universe is moving apart. Space itself, the invisible stage on which everything dances, is stretching. For most of human history, people imagined the universe as fixed and eternal. The stars were thought to hang motionless, like jewels sewn into a black velvet cloth. But a century ago, astronomers began to notice something strange. The galaxies in every direction seemed to be drifting away from us. Their light stretched and softened into red hues as they receded. It was as if space itself were breathing outward. What began as a quiet observation became one of the most profound realizations in science. The universe is expanding. An expansion, like all things, has its own tempo. In the early days of cosmology, scientists believed gravity would eventually slow this motion. Perhaps, they thought, the pull between galaxies would one day stop the outward drift, even reverse it, drawing everything back together in a big crunch. But when astronomers studied the faint glow of distant supernovae, ancient stars exploding billions of years ago, they found something unexpected. The universe was not slowing down. It was speeding up. There was no clear reason for this acceleration. Nothing visible seemed to push the galaxies apart, and yet the data was unmistakable. The expansion wasn't just continuing, it was growing faster. Somewhere, within the fabric of space, a quiet force was at work. A pressure not of wind or matter, but of emptiness itself. Scientists called it dark energy, though that name is more mystery than description. It's not dark in the way shadows are dark. It's simply unseen, an invisible whisper that urges the cosmos to drift further apart. Imagine ink dropped into water, spreading outward in graceful swirls. Each drop moves away from the others, not because of a push, but because the space between them grows. Galaxies behave the same way. They're not racing through space like ships on a sea. The sea itself is expanding. Even the distances between clusters of galaxies, once held together by gravity, are beginning to widen. For now, our own galaxy and its future partner Andromeda are bound tightly enough to resist that outward pull. They will merge long before dark energy pries them apart. But farther away, the story is already changing. The great filaments of galaxies that once formed a cosmic web are stretching thinner. Over trillions of years, the space between them will swell until each cluster stands alone, surrounded by an ocean of deepening black. If there are beings alive in that far-off future, their skies will be almost empty. The nearby stars will remain, but everything beyond will have faded from view. No light from distant galaxies will ever reach them. The universe will have grown too vast, its expansion too fast. To them, the cosmos will seem small, static, and isolated, a serene self-contained bubble of stars floating in eternal night. They may never know that the wider universe once teemed with light. It's a haunting image, but not a hopeless one. The universe, in letting go, is not dying, it is simply relaxing. The energy that once drove creation now diffuses into stillness, like the fading vibration of a bell long after it has been struck. Every galaxy that drifts away carries with it the memory of its neighbours, a piece of the pattern that once connected them all. This quiet dispersal also gives us perspective. The fact that we live now, at a time when galaxies are still visible, when the night sky still holds the story of its own beginning, is an extraordinary coincidence. We exist in a narrow window of cosmic history, late enough for stars and planets to have formed, but early enough to still see the evidence of the universe's birth. One day, all of that will fade from view. The great tapestry will unravel, leaving only local threads. You can think of it as the universe exhaling. After a long age of gathering, of forming stars and galaxies and clusters, it now releases everything back into silence. Gravity once held things close. Now, dark energy coaxes them apart. This balance between pull and release is the same rhythm we've seen again and again, the breath of creation written across scales both human and cosmic. Sometimes, the simplest truths in science are also the most poetic. Space itself is not a void but a fabric, a flexible, living structure that can stretch, twist, and ripple. When that fabric expands, distances grow, not because the galaxies move, but because the stage beneath them widens. The light from distant stars stretches too, its wavelengths lengthening like a slow sigh, turning from blue to red to invisible infrared until it disappears altogether. Time and space are not just arenas where things happen. They are participants in the story. It's tempting to ask what lies beyond, what space is expanding into. The answer is quiet and strange. It's not expanding into anything. The expansion happens everywhere, at once, with no edge, no outside. The universe is not growing inside a container. The container itself is growing. It's like watching a painting that paints itself, every moment pushing the frame wider, the colours stretching outward without end. If we follow this acceleration far enough into the future, the outcome depends on the nature of dark energy, something we still don't fully understand. Perhaps it will remain constant, letting the universe expand forever, growing colder and quieter as time drifts toward infinity. Or perhaps it will grow stronger, pulling everything apart down to the atoms themselves, a cosmic unravelling sometimes called the Big Rip. But even if that happens, it will unfold so slowly over such unimaginable stretches of time that all witnesses will have already faded into legend. There's a quiet grace in this vision. The universe began in a fierce rush of creation, and it may end in a long sigh of dispersal. Both are part of the same motion, the same breath. Everything that ever was, stars, galaxies, even thought itself, belongs to this great expansion. And if the cosmos has taught us anything, it's that every release makes space for something new. The night sky, for now, still carries the evidence of that expansion. The faint redshift in the light of distant galaxies, the stretched hum of ancient radiation, the silence between the stars. We live in the afterglow of beginnings, drifting within a cosmos that is slowly learning to let go. As our path unfolds further, we'll follow the light into the future, to the small, quiet stars that will outlast all others, glowing faintly in a universe that is already growing cold. There will come a time when the great galaxies, once so full of light and motion, will fall into a deeper stillness. The bright generations of stars, the giants that lived and died in radiant bursts, the suns that warmed their worlds, will have spent their fuel. Across the vastness, the night will grow dimmer. Only the smallest and most patient stars will remain. These will be the red dwarfs, the universe's final candles glowing faintly in the dark. A red dwarf is a humble kind of star. It burns slowly, quietly, and efficiently, sipping its hydrogen instead of consuming it in a rush. Where a giant star might live only a few million years, a red dwarf can endure for 100 trillion. That number is almost impossible to imagine, its time stretched beyond the limits of any language we have. If you were to count every grain of sand on every beach on Earth, you'd still be far short of that measure. For all practical purposes, these little stars are eternal. They shine with a deep orange-red glow, soft and steady, not much brighter than a single ember in a vast fireplace. Most of them are so faint that we cannot see them from Earth without telescopes, yet they outnumber all the larger, brighter stars combined. They are the quiet backbone of the cosmos, keeping watch long after the brilliant ones have vanished. Around many of them, tiny planets circle close, warmed by a light so gentle that their days and nights might blend together. If life has found a way to exist there, it must have learned patience beyond our understanding. In this distant era, galaxies will no longer be the crowded cities of stars they once were. They will be quieter, like small towns at the edge of winter. The few remaining stars will burn low, scattered like lanterns across an enormous dark plain. The universe will still expand, but more slowly now, its energy spread thin. Time will seem to pass differently, stretched and unhurried, like the last light fading from the horizon. Even then, creation hasn't truly stopped. In the faintest reaches of space, gravity will still gather stray clouds of gas, forming the rare new star. But these births will be few and far between, like the final notes of a symphony echoing through an empty hall. Most of the remaining energy will belong to the small, enduring fires, the red dwarfs that refuse to fade. As they age, their light will grow softer still. Over tens of trillions of years, they will exhaust the last of their hydrogen and cool into pale, dark embers called white dwarfs. These stars will no longer shine by fusion. They will only glow from the leftover warmth of what they once were. Picture a bed of coals long after the fire has burned away, each faint spark a memory of light. When even that heat is gone, the white dwarfs will turn cold and black, becoming invisible to any eye that might still exist. Astronomers call these black dwarfs, though none have ever been seen. They are predictions of the far future, stars so ancient that they've forgotten how to glow. The universe at that point will be filled mostly with these quiet remnants, drifting like stones in an endless sea. But this slow fading doesn't feel tragic when you think about it closely. It feels peaceful, like the natural end of a song. The universe began in a blinding explosion of light, and now, after an incomprehensible span of time, it is learning to rest. The last stars are not fighting the dark. They are blending with it, carrying the memory of all that came before. Imagine standing in that era, if such a thing were possible. The sky would no longer blaze with constellations. Instead, you'd see only a few scattered points of red, like the dying embers of a great fire. The Milky Way's shape would be gone, its spiral arms dissolved into silence. Each surviving star would sit in its own small bubble of light, surrounded by endless night. The distances between them would be so vast that even light would take longer than the age of the universe to cross from one to another. If any beings existed then, their sense of time would be unlike ours. They might watch a single star dim over what we would call billions of years, their calendars measured not in seasons but in eternities. Perhaps they would look at those fading lights and see not endings, but continuity. A universe completing its long exhale after a lifetime of creation. This quiet future invites a kind of serenity. The universe is not rushing toward catastrophe, it's gliding gently toward equilibrium. The fires going out one by one, but the ashes remain, floating in the dark, carrying the imprint of their light. The cosmos is simply fulfilling its own rhythm, trading energy for stillness, brightness for balance. And in that balance lies something beautiful. The heat and movement that once forged galaxies will settle into a steady calm, the way a storm eventually fades into a clear sky. Every particle, every fragment of dust, every faint photon will have done its part in the long, slow weaving of existence. Nothing is wasted. The image of the last stars glowing softly at the end of time might seem lonely, but in another sense, it's comforting. It reminds us that the universe does not fear darkness. It moves toward it gracefully, without haste or resistance. The same light that began in the Big Bang still travels, still touches the edges of what remains. Even as the stars cool, that ancient radiance continues its journey, spreading thinner and softer until it becomes the quiet background hum of space itself. As we drift deeper into the story, we reach the point where light grows scarce and the night becomes nearly perfect. The stars have faded, but their remnants remain. White dwarfs, neutron stars, and black holes, all sharing the same long silence. This is the beginning of what astronomers call the degenerate era, though we might think of it instead as the age of peace, when everything that once burned finally rests. What follows after the last stars fade is not darkness in the way we know it. It is something softer, quieter, an immense stillness that seems almost sacred. The universe, once full of blazing light and restless motion, begins to slow its breathing. This is the era of remnants, when all that remains of creation are the quiet bones of what once burned. Astronomers, with their love of naming, call it the degenerate era. But that word degenerate doesn't capture its grace. It isn't decay, it's peace. Imagine space now as a vast cool ocean. Scattered through it are the leftovers of billions of suns, white dwarfs, neutron stars and black holes. They drift through the dark like pebbles resting in the tide, their light long gone but their presence enduring. There is no longer the bright chorus of galaxies, no more new stars being born from the ashes of old ones. The orchestra of creation has played its grand finale, and what lingers is the hush that follows, the kind of silence that invites listening. White dwarfs, once the embers of medium-sized stars like our sun, are still warm in this far-off time. They glow faintly, not from fire or fusion, but from the last traces of their stored heat. Over billions upon billions of years, that glow will fade. As they cool, their colour will shift from white to red, from red to black, until they become invisible. When the last of that warmth leaves them, they will become black dwarfs, stars that still exist but no longer shine. If you could hold one in your hand, it would feel impossibly heavy, though no larger than the Earth. Its surface would be smooth and hard, its atoms crushed so tightly that they behave more like a single structure than separate pieces. Inside it, nothing moves. Even the atoms are frozen in their places, like notes held at the end of a song that will never resolve. Around them drift the ghosts of more massive stars, neutron stars and black holes. Neutron stars are incredibly dense, the size of a small city, but with the weight of entire suns. They are made of matter pressed to its limit, so compact that a spoonful would outweigh a mountain. In the darkness of this late universe, they spin slowly, like dim lighthouses still turning long after their beams have gone out. And then there are the black holes, the most mysterious relics of all. Once they were the hearts of massive stars or the centres of galaxies. Now they are the final keepers of matter, gathering what little remains. They are not holes in the ordinary sense. They are regions where gravity is so strong that even light cannot escape. What falls into them is not lost exactly. It becomes part of their silence. Over unimaginable stretches of time, these black holes too will fade. Stephen Hawking once proposed that they slowly leak energy, radiating away their mass until, after an eternity, they vanish completely. To describe how long that will take, we would need numbers with more zeros than could fit across the visible universe. It is a time so vast that even the concept of counting breaks down. Imagine every second of your life stretched into a thread. Then imagine those threads woven together, one for every human being who ever lived. The length of that tapestry would still be shorter than a single breath in this new cosmic age. As the black holes dissolve, the last traces of what we call structure will fade with them. The galaxies that once spiraled through the heavens will have evaporated. The matter that formed them, protons, neutrons, atoms, will begin to decay, breaking down into smaller and smaller pieces until nothing remains but faint whispers of energy. Even those particles scattered across the deep will drift apart until they are separated by distances so vast that they can no longer interact. And yet, in this absolute stillness, there is a strange beauty. It is the beauty of completion. Every act of creation, every flare of light, every heartbeat, every thought, all of it has already happened. The story has been told in full. The universe is not lost, it is fulfilled. If you could float there, in that final quiet, you would not feel fear. There would be no temperature, no pressure, no movement to stir the air. It would be a place beyond time's reach, where everything has come to rest. The background glow that once filled the universe, the faint echo of the Big Bang, would have faded into cold silence. Space would no longer hum. Time itself would have slowed to a crawl, almost meaningless because nothing remains to measure its passing. This is what the physicists mean when they say entropy wins. Entropy is not destruction, it's balance. It's the spreading out of energy until everything is equal, until no difference remains between one place and another. When that happens, time, which depends on change, no longer has direction. There are no events to separate a before from an after. The arrow of time, which once shot forward through explosions and growth, now lies flat. But even this final calm has a kind of tenderness. Everything that ever existed still lingers here in some form. The atoms that once built worlds are still scattered across the dark, just quiet now. The light that once illuminated galaxies still travels outward, endlessly diluted but never entirely gone. The universe has become a memory of itself, vast, silent, and at peace. If you listen closely enough, you might imagine you can still hear the echoes of its earlier ages, the roar of the Big Bang, the humming of stars, the slow murmur of galaxies drifting apart. Those sounds are gone, but their patterns remain, written invisibly into the structure of space. Every particle, every faint photon carries the trace of its origin. The universe is still telling its story, just more quietly now. And in that quiet, something profound happens. Time no longer moves as we know it, but existence continues, serene and unhurried. It is as though the cosmos, having burned through its passions and storms, has finally reached a perfect rest, a state not of death, but of deep, eternal sleep. As we follow this silence further, we begin to wonder whether this is truly the end or just another transformation. Because even as the universe settles into stillness, some theories whisper that what looks like an ending may, in ways we can't yet grasp, become the beginning of something else. In the deep stillness of the late universe, where most lights have faded and only the memory of creation drifts through the dark, there remain a few places where gravity has gathered itself into something almost sacred. These are the black holes, the hungry shadows of the cosmos. They're not things in the usual sense. They are places where space folds in on itself, where time bends so deeply that even light, swift and tireless, cannot find its way out. You might picture a black hole as a kind of wound in the fabric of reality, though that word, wound, feels too violent. It is more like a scar, a place where the universe has remembered the weight of what once was. Around it, space stretches like soft fabric drawn tight, and light that wanders too close begins to spiral inward, circling faster and faster until it disappears. The black hole does not swallow in anger or hunger. It simply holds, as if keeping what the universe no longer needs. They are born from endings. When a massive star spends the last of its fuel, gravity finally wins the long struggle against its own light. The outer layers collapse inward, and in a fraction of a second the star's core compresses beyond all measure. It is as though an entire sun has been folded into a single, invisible point. The collapse is so complete that not even atoms survive it. Matter becomes a something else. Pure geometry, pure gravity, pure silence. At first, black holes reveal themselves only through what they erased. Astronomers would see stars orbiting invisible partners, or light bending where there seemed to be nothing. They knew something massive had to be there, but no telescope could capture it. Even now, the image we call a photograph of a black hole is not a direct picture of the hole itself, but of its outline, the halo of light being twisted and heated around its edge, the event horizon. Beyond that border, no message ever returns. To understand how strange that is, imagine tossing a note into a river that never ends. Once it crosses the horizon, it doesn't vanish, it keeps falling, forever, toward a centre it will never reach. Time itself slows there. To an outside observer, anything falling toward a black hole seems to freeze in place, taking longer and longer to move, as though caught in a loop of almost arrival. The closer it gets to the edge, the slower its clock runs. In a way, the black hole is not just the end of space, it is the slowing of time. But from inside, if there were any inside in the way we understand it, the story would feel different. To whatever falls in, the journey continues. There is no edge, no pause, only motion toward the centre, where all distances converge. Scientists call that point a singularity, though it's less a place than a limit of knowledge. It's where the equations that describe reality stop working, as if language itself forgets how to speak. And yet, even in their strangeness, black holes are not the monsters they were once imagined to be. They are necessary. Without them, galaxies would not exist in their familiar shapes. At the centre of nearly every large galaxy lies one of these invisible anchors, millions, sometimes billions, of times more massive than our Sun. They bind the stars together, their gravity sculpting the orbits that give galaxies their luminous spirals. You could say that every star in the Milky Way dances to the rhythm of a shadow it can never see. In their way, black holes are the universe's memory keepers. Every bit of matter or energy that falls into them leaves an imprint, perhaps not lost entirely, but written into their surface in ways we don't yet fully understand. Some physicists suggest that black holes store information about everything they consume, like vast cosmic libraries hidden beneath veils of darkness. If that is true, then nothing is truly gone. It is simply transformed into a form we cannot yet read. There is a strange comfort in that thought. The same universe that began in an explosion of light now hides its secrets inside silence. The two extremes, creation and collapse, are reflections of each other. Every beginning carves the path toward an end, and every end leaves behind the seed of a new beginning. The black holes are reminders of that symmetry. They are not destroyers, they are keepers of balance, and they are not completely invisible. When matter spirals too close to a black hole, it heats up, glowing fiercely before crossing the horizon. From far away, this looks like a bright ring of fire encircling a perfect darkness. The contrast between the two, the last brilliance before silence, is one of the most beautiful sights in the universe. It's as if the cosmos itself paints a frame around mystery, a final moment of radiance to mark the boundary between knowing and not knowing. If you were to drift near one, safely far from its pull, you would feel the strange calm of its presence. The stars behind it would appear distorted, their light bending around the invisible shape. You would see the universe twisted into a circle, everything reflected in every direction. It would be terrifying, yes, but also awe-inspiring. An encounter not with death, but with the pure architecture of existence. Perhaps that is why black holes capture our imagination so deeply. They remind us that there are places where the rules we know stop working, where the universe whispers, beyond this point, something else begins. They stand at the border between physics and poetry, between what can be measured and what can only be felt. And though they seem eternal, even black holes have their fates. They too will one day fade, not with an explosion, but with a long and gentle release, a slow unravelling of gravity's last breath. But before we reach that silence, let's linger a little longer in their presence, to listen to what these quiet giants have to teach us about endings, and about the soft light that still escapes even from the deepest night. If the black holes are the universe's quiet vaults, then this is the part of the story where even those vaults begin to open. For a long time, scientists believed that nothing could escape from a black hole, that once light crossed the horizon, it was gone forever. The very definition of a black hole was finality itself, a one-way door. But then came a small, unexpected whisper in the dark, a thought from Stephen Hawking that would change how we imagine eternity. He suggested that even darkness leaks a little light. It sounds impossible, doesn't it? Yet Hawking's idea came from a very simple realization about the fabric of space itself. What we call empty space is never truly empty. It hums with tiny flickers of energy, pairs of particles that appear and vanish faster than any clock could measure. They're like brief sparks in a fire that never quite ignites. These pairs are born everywhere, even along the edges of black holes. Normally they meet and disappear again almost instantly, leaving no trace. But at the rim of a black hole, the event horizon, something different happens. Every so often one of these paired phantoms falls inward, pulled across the edge while its twin escapes. To an observer far away, that single survivor appears as a faint glow coming from the darkness. The escaping particle carries away a tiny piece of the black hole's energy. Slowly, imperceptibly, the black hole loses mass. This is what we call Hawking radiation, though you could think of it more gently as the last breath of gravity itself, a slow exhalation spread over unimaginable ages. It isn't a flash or an explosion. It's more like a whisper stretched across eternity, a soft leak of warmth into an ever-cooling universe. If you could somehow wait long enough, far longer than the lifespan of any star or galaxy, you would see even the largest black holes fade. First, the smaller ones would thin away, glowing faintly before vanishing. Then, the great supermassive ones, the hearts of galaxies, would follow. Their light would be so faint that it would barely ripple the dark. But it would be there, the last warmth of creation slipping gently into silence. How long would this take? The numbers are so vast that they hardly mean anything. Imagine writing the digit 1, followed by 100 zeros. That's still not enough. These timescales stretch beyond the life of every atom, beyond anything the human mind can truly picture. And yet, no matter how far you extend them, they remind us of something profound. Even in its deepest darkness, the universe does not hold on forever. It releases. There's a kind of grace in that. Black holes, which once seemed like the ultimate prisons, turn out to be patient givers. The energy they slowly leak will fill the surrounding void with the faintest glow, a sea of soft, low light that will ripple outward forever. Even when all the stars have died, even when galaxies have gone cold, there will still be this gentle murmur of radiation, the last heartbeat of space. Scientists sometimes describe this process in terms of quantum fluctuations and virtual particles, but you don't have to memorize those words to feel what they mean. You can think of it as a balance being restored, a final sharing of energy between what has fallen and what remains. For every shadow, a faint shimmer. For every collapse, a soft release. The universe, it seems, keeps no permanent debts. If you could stand safely near a black hole during this slow unwinding, you wouldn't notice anything change. The event horizon would still look as black as ink. But if you had eyes that could see far beyond visible light, into the wavelengths of the deepest heat, you might sense a faint warmth at its edge. It would not glow like fire. It would breathe, almost imperceptibly, like the pulse of a creature in sleep. Over eons, that warmth would grow as the black hole shrinks. The smaller it becomes, the faster it radiates, the quicker it fades. By the time the last moment comes, it would release a final tiny flare. Not a roar, not a bang, but a sigh. The dark would brighten briefly, like a candle being blown out, and then the horizon would be gone. What remains after that? Only the faint residue of the radiation itself, drifting outward into an already thin and quiet cosmos. The black hole leaves no scar, no trace, only the memory of gravity, the echo of something that once shaped galaxies. The universe, piece by piece, is learning to let go of its own weight. There's something deeply human in this story. We too are made of things that were never meant to last, yet in the process of fading, we give something back. Every breath you take returns part of what was given to you: warmth, carbon, light. The black hole does the same, only on the grandest scale imaginable. It teaches that even what seems most absolute can still yield, still soften. When Hawking first proposed this, some found it unsettling. The idea that black holes could evaporate challenged everything we thought we knew about permanence. But perhaps that's the beauty of it. Nothing, not even darkness, is absolute. Every edge contains its own opposite, every silence its own echo. And so, after an age so long that language itself would have vanished, after every star and atom has dissolved into light, the final shadows will grow thin and fade. The universe will be left with nothing solid, nothing bright, only a smooth, faint hum of energy spread evenly across endless space. The last sigh of gravity. To some, that might sound like an ending. But endings are simply thresholds in disguise. The story of the black holes reminds us that even in the deepest quiet, The universe is still in motion, releasing, transforming, balancing. And perhaps, somewhere beyond this horizon of silence, something is already stirring, ready to rise again from what remains. As we drift onward, our journey will now carry us toward that threshold, the edge of the possible, where science meets mystery and where curiosity becomes the bridge between what is known and what might still be. The further our story travels, the more it begins to blur the line between what we know and what we can only imagine. At this edge of cosmic time, where even black holes have taken their final breath, the universe becomes less a place and more a question. And here, in that vast uncertainty, human beings still look up, still ask, still build, still wonder. It's easy to forget how improbable that is. Somewhere in this enormous expanse of cooling stars and fading light, tiny creatures on a small blue planet began to wonder what it all meant. They built instruments of glass and metal, pointed them toward the sky, and waited for faint ripples of truth to reach them. They carved tunnels beneath mountains, constructing enormous circles of light where particles could collide at nearly the speed of thought. They called it the Large Hadron Collider, but in simpler terms it's a kind of time machine, a ring built to glimpse the universe when it was still young enough to remember its own birth. Inside those rings, invisible sparks collide and shatter, revealing what matter is made of. Every flash is a whisper from the beginning. The same conditions that once filled the newborn universe recreated for a fraction of a heartbeat. These experiments, though grounded in equations and magnets, are really acts of faith. They are humanity's way of asking the oldest question in existence: what are we made of, and why does anything exist at all? You could imagine it this way. The universe looks at itself through our eyes, searching its own depths. Every discovery, every particle traced is the cosmos learning a little more about its own reflection. We are, in some strange and humble way, the part of the universe that has become aware of itself. When scientists talk about these experiments, they use the language of physics, quarks, bosons, fields. But beneath the vocabulary lies something tenderly human. The Large Hadron Collider, spinning quietly underground near Geneva, is a modern echo of ancient fires where people once gathered to watch the stars. Back then they told stories of gods and creation. Now we use data, detectors, and mathematics. But the emotion is the same, or curiosity, the gentle ache of wanting to understand the infinite. Beyond the subatomic, there are theories that stretch the imagination even further. Some scientists suggest that the universe we know, the one filled with galaxies, stars, and everything between, might not be all there is. They speak of hidden dimensions, layers beyond our perception, like threads running beneath a woven cloth. It can be hard to picture something that lies beyond three-dimensional space, but there's a simple way to feel it. Imagine a small insect walking across a still pond. To the insect, the world seems flat, a smooth surface stretching in every direction. It has no idea that below that surface a vast depth exists. Fish move through it, unseen, yet they are just as real. We might be the insect living on the thin surface of a larger reality, sensing only the ripples that reach us. If these deeper dimensions exist, they might cradle universes beyond ours, entire realms where time flows differently, where the laws of physics twist into new forms. Some might be empty, others might burn with different kinds of stars. It's a dizzying thought, but also a gentle one. Maybe our cosmos isn't alone. Maybe creation too has its companions. Of course, we can't see these hidden dimensions directly. For now, they are mathematical possibilities, glimpsed only through hints in equations and strange patterns in the data. But the beauty of science is that it keeps reaching, even when the answers seem impossibly far away. Curiosity is the universe's oldest instinct, and in us it has learned how to ask questions. Every new discovery brings us a little closer to what feels like the edge of the possible, that thin place where our understanding meets the unknown. The closer we get, the more delicate our language must become. Numbers give way to metaphors, equations soften into wonder. The universe, after all, was not built to be solved like a puzzle. It was built to be experienced. Sometimes the search for truth can feel like standing at the shore of an endless ocean, dipping your hands into the water knowing you can't hold it all. Yet every drop you lift reflects the whole sky. In that reflection, the infinite and the finite meet, the cosmos and the human mind sharing the same light. If you've ever stared at a night sky clear enough to see the Milky Way, you've felt this already. The quiet pull of something larger than comprehension. The realization that every atom in your body was once part of a star. And perhaps in that recognition, the boundaries between observer and universe begin to blur. You're not separate from the cosmos you study. You're its continuation, the echo of its earliest thought, wondering what it means to exist. Our experiments, our colliders, our telescopes, they are the tools of that curiosity. Each one extends the reach of our senses, letting us see a little deeper into the pond. And though we still know so little, what we have learned already is astonishing. That space and time themselves may not be the foundations of everything, but the consequences of something deeper. Some physicists imagine that our universe is like a bubble floating in a vast cosmic foam, with other bubbles expanding beside it. If two bubbles touch, they might exchange matter or energy, or even give birth to something new. Whether or not this picture is true, it reminds us of something ancient. The idea that creation is never a single event, but an ongoing act. There's humility in reaching for what we can't yet see, but there's joy too, because every mystery we explore brings us closer to what we are. To study the universe is to listen for its heartbeat, and in those faint rhythms to hear our own. The more we learn, the more we realize that knowledge is not the end of wonder, it's the beginning of it. Science does not erase mystery, it deepens it, turns it from superstition into symphony. The edge of understanding is not a wall, it's a horizon, and beyond every horizon, there's always another sunrise waiting. As we drift from the bright frontier of knowledge toward what comes after it, our story now carries us back into the silence, to a universe without witnesses, where time itself may lose its meaning. There, in the calm after all creation has quieted, we'll ask a final question. Does time still exist if nothing remains to mark its passing? Imagine a night so deep that even the word night no longer fits. A silence that does not wait for sound, a darkness that does not expect dawn. The stars are gone now. The black holes have breathed their last faint sigh of warmth. The galaxies have dissolved into a fine mist of fading particles drifting through immeasurable space. The universe, once alive with brilliance and motion, has entered its long stillness. This is the world after endings, the universe without witnesses. There are no eyes left to see, no minds left to measure, no heartbeat to mark the passage of a second. Matter itself has thinned into a ghostly vapour of subatomic fragments, moving so far apart that they almost forget they were ever neighbours. What remains is a vast and nearly perfect calm. In this quiet, time becomes slippery. We usually understand time through change, through the ticking of a clock, the flicker of a candle, the turning of the earth. But what happens when nothing changes anymore? When no stars are born, no atoms collide, no warmth rises or falls? Time loses its rhythm. It stretches until it no longer feels like motion but stillness. The clock still ticks perhaps, but in an empty room where no one is left to hear it. Some scientists call this state the heat death of the universe. It sounds grim, but the phrase is misleading. It doesn't mean fire or decay. It means the end of difference, when all the energy in the cosmos is spread evenly, like water poured across a flat surface. No part is warmer or colder, brighter or darker. Everything has reached perfect balance. And in that balance there is peace. If you could somehow exist then, as a thought or a flicker of awareness, the view would be strange beyond imagining. The sky would be featureless. No stars, no galaxies, no horizon. Even the concept of up or down would be meaningless, because there would be nothing left to orient against. The universe would appear infinite and uniform, a silent ocean without waves. And yet, even here, traces of what once was still drift. Photons, those tiny packets of light that once painted galaxies and warmed the early universe, continue to travel. They are stretched thin now, their energy faint and cool, their wavelength longer than any radio signal. They are the echoes of everything that ever burned, still moving outward though there's nothing left to reach. The universe is filled with these ancient whispers, too faint for ears, too slow for time. When physicists describe this age, they use immense numbers, intervals so long that writing them out would take the lifetime of a star. But even those numbers feel inadequate. The deeper truth is that time, as we understand it, has unravelled. Without change, time has no reason to flow. It becomes more like an idea than a dimension, a ghost of motion lingering where motion used to be. This is where science begins to shade into philosophy. Can time exist without anything to mark its passage? If no event occurs, if no difference arises between one moment and the next, is there still a next? Maybe time is not an external thing, but a relationship, a measure of how one state becomes another. When all states are the same, when nothing changes, the relationship ends. Time falls asleep. The universe, then, is not dead. It's resting. It's not cold in the way winter is cold, or silent in the way midnight is silent. It's simply still, perfectly still. It has reached the point of ultimate symmetry, the long-awaited pause after creation's endless song. The particles that remain no longer have stories to tell, because they've all told the same one: expansion, cooling, release. But what makes this vision haunting is the absence of witnesses. There will be no consciousness left to reflect, no memory to preserve, no curiosity to ask what comes next. The universe will continue to exist, but without awareness, existence becomes something different. Perhaps it becomes potential, a blank page waiting for a new hand to write upon it. Maybe that's the hidden beauty in this idea. If time truly disappears when nothing changes, then the story of the universe doesn't have a definite end. It simply stops telling itself, like a book whose final page is blank, waiting for the next chapter to be imagined. And if the laws that govern matter and energy have taught us anything, it's that even stillness hides possibility. Out of equilibrium, movement arises. Out of silence, vibration returns. It might take a span of ages beyond all comprehension, but perhaps somewhere within that cosmic quiet, something begins to stir again. A quantum fluctuation, a brief, spontaneous ripple in the vacuum, a small imbalance in the smoothness, a breath, and from that breath, a spark, not a sound, not a flash, just the faintest tremor in nothingness. It could be enough, because the universe itself was born from something very much like that, a tiny irregularity, a single ripple in an otherwise perfect void. We might never know if this happens. There would be no one left to see it, no eyes to witness the moment when stillness gives birth to movement again. And yet, it is a comforting thought that creation and quiet are not opposites, but two halves of the same cycle. The universe's silence, far from being a final resting place, might be the pause between breaths. Somewhere beyond this unimaginable stillness, the laws of physics might fold in on themselves, rewriting the fabric of space and time. Perhaps the energy released by the last fading black hole plants the seed for a new beginning. Perhaps a new cosmos expands out of this one's calm. Different laws, different stars, a new version of reality beginning again from the dust of the old. The question then changes. It's no longer will time end, but What happens when it forgets itself? Does it truly stop, or does it dream? And if time can dream, what might it dream of? Maybe it dreams of warmth, of gravity's pull, of light gathering into stars. Maybe it dreams of atoms building worlds, and of those worlds giving rise to thought. Maybe it dreams of someone like you, looking up at the night sky, asking where it all began. And so, even in this imagined silence, this long stillness without witnesses, the possibility of renewal lingers. The story may be asleep, but not ended. It waits quietly for its next awakening. As we drift from this vast quiet into the next part of our journey, we will follow that faint thread of possibility, the idea that beyond the universe's stillness, something might rise again. The whispers of forever are not silent after all, they are simply waiting for the next voice to speak. The story could end here, with a universe at rest, time asleep, and silence spread evenly across eternity. But the human mind has never been content to leave endings untouched. We turn the last page and look for what might come next. Even when the cosmos has gone still, we can't help but wonder, is that truly the end, or only the quiet breath before another beginning? Science, too, has its ways of dreaming. Some theories whisper that the universe will continue to expand forever, drifting into a vast and endless calm. Others imagine more dramatic finales, a great unravelling, or a collapse and rebirth. Each idea tries to glimpse what lies beyond the horizon of meaning, where our equations begin to fade into poetry. The first vision is the gentlest, the heat death, the universe's slow slide into perfect balance. We've already drifted through its description, a cosmos that grows colder and quieter until every source of motion is spent. It's not destruction, only rest. Time itself smooths into silence. But there are other possibilities, more turbulent, more uncertain. One of them is sometimes called the Big Rip. It begins with the same expansion that we observe today, space stretching in all directions. But if the mysterious pressure that drives that expansion, the thing we call dark energy, continues to grow stronger, then the stretching won't slow down. It will accelerate endlessly until gravity, the great binder of things, can no longer keep hold. At first, the galaxies drift apart. Then the stars within them lose their orbits. Later, even planets unbind from their suns. If this expansion keeps growing, stronger, there comes a point where the atoms themselves can no longer hold together. Everything is pulled apart, not by violence, but by inevitability, by the calm insistence of space itself. The universe becomes a fabric unravelling from its own edges. This vision is haunting, but strangely beautiful, because even in that dissolution there is motion. The same energy that once birthed galaxies continues to write the final lines of the story, pulling every thread until only light remains. It's a slow erasure, but not a cruel one. More like the tide reclaiming footprints on sand. Another possibility looks in the opposite direction. Instead of expanding forever, the universe might one day grow heavy again. Perhaps dark energy will weaken or reverse, allowing gravity to reclaim its strength. If that happens, all the galaxies and stars that have drifted apart would begin to fall inward once more. The universe would contract, folding its vast distances back into a smaller and smaller space. Over eons, everything would grow denser, hotter, brighter, until all of creation collapses into a single, blinding moment. Some call this the Big Crunch. It's a mirror image of the Big Bang, an ending that looks like a beginning played backward. In that final instant, the energy trapped within every atom could ignite again, sparking a new expansion, a new universe. In that sense, the cosmos might be cyclical, breathing in and out across infinite ages, each death the seed of a new birth. Roger Penrose, a physicist with a poet's soul, offered a vision along these lines. He imagined that as the universe expands and matter thins, time itself might lose meaning, and that in such a state, the distinction between infinite future and instant beginning could vanish. The last sigh of one universe might simply flow into the first breath of another. He called this idea conformal cyclic cosmology, but you could think of it more simply as the recycling of eternity. Picture a wave fading into the sea, its ripples smoothing into calm. To the ocean, nothing is lost. The water remains, waiting for the next wind to rise. When that happens, another wave forms, different in shape but made of the same essence. Perhaps the universe works the same way. Perhaps every Big Bang is just the sea remembering how to move again. These theories don't compete so much as they coexist, reflections of our longing to see continuity in all things. Whether the cosmos drifts into stillness, tears itself apart, or folds inward to be reborn, the question that remains is not only what happens to matter, but what happens to meaning. Because if the universe truly ends, what happens to the idea of it? Does beauty vanish when there are no eyes to see it? Does time vanish when there are no minds to count its rhythm? Or is meaning woven so deeply into existence that it survives every collapse, waiting to express itself again in some new form of awareness? Even if no, observer remains, the pattern itself might endure, not as memory, but as potential. The laws of physics, the balance of gravity and energy, might re-emerge in the next universe, whispering the same possibilities in a new language of stars. Maybe the constants that shape our world, the strengths of forces, the weights of particles, are like musical notes, reappearing in every cosmic symphony, though each time the melody changes. You could think of existence not as a straight line, but as a loop of transformations, each universe blooming, fading, and blooming again. To us, this cycle feels infinite, but perhaps to the cosmos, it is simply natural breathing. Expansion and collapse, creation and rest, all part of the same eternal rhythm. And yet, there's something uniquely human about asking these questions at all. To stand beneath a night sky, to look out into the dark, and to wonder what happens when everything ends. That act itself is a kind of defiance against oblivion. We cannot escape the horizon of our understanding, but we can face it with wonder instead of fear. The edge of meaning is not a wall, it's a mirror. When we stare into the unknown, what looks back at us is the reflection of our own curiosity, our own need to keep searching. The universe may one day end, but the act of asking ensures that its story continues, through thought, through imagination, through every quiet mind that dares to look beyond. As we drift deeper into this reflection, our next step carries us toward time itself, not as a ruler or a direction, but as a circle, a gentle turning that never truly stops. The arrow of time, it seems, might one day bend back upon itself, leading us to the oldest idea there is, that eternity isn't an endless length, but endless renewal. If you watch the sunrise and sunset enough times, you start to feel that life moves in circles. The light leaves and returns, winter fades and comes again, old leaves fall so new ones can grow. The rhythm is so steady, so natural, that it's easy to forget that our science once taught us to think of time as a straight line, an arrow with a single direction. It begins with a big bang and ends somewhere in the far dim future. But perhaps that arrow, like everything else in nature, eventually curves back toward its source. For thousands of years, people believed that time was cyclical. The ancients looked at the heavens and saw repetition, not progression. The Hindu sages spoke of cosmic ages called kalpas, immense cycles of creation, destruction, and renewal that repeat endlessly, each one a breath in the life of Brahman, the eternal universe. The Greeks imagined the same rhythm as the eternal return, a cosmic wheel in which every event, every life, every love and sorrow would happen again not once but infinitely. To them, time was not something to escape or conquer. It was something to live within, a flowing circle where every ending folded back into a beginning. You can feel that same understanding hidden in old myths and rituals, in harvest festivals and solstices, in every story that ends with rebirth. These were humanity's first attempts to align our hearts with the rhythm of the cosmos. Modern science replaced those circles with lines. It gave us beginnings measured in billions of years and endings so far ahead that even imagination grows tired trying to reach them. Yet as our understanding deepened, we found hints that the universe itself might still remember its cycles, that the old wisdom was not entirely wrong, only incomplete. Entropy, for example, gives time its forward direction, the slow spreading of energy, the transformation of order into disorder. It's the reason why eggs don't unbreak, why smoke doesn't return to the fire, why stars grow old instead of young. But even entropy, that great director of the cosmic play, might one day lose its authority. If the universe continues to expand, its energy will spread so thin that disorder and order will become indistinguishable. At that point, the arrow of time might no longer have anywhere to point. Without difference, there is no direction. Some thinkers wonder whether, when everything becomes perfectly balanced, time itself might fold over and restart, not as a copy of the past, but as a new variation of it. The final calm of one universe could become the seed of the next. The end of one arrow becomes the tail of another. It's tempting to see this not as science, but as poetry. Yet even in physics, patterns echo this possibility. The orbits of planets, the spinning of galaxies, the oscillations of particles. Everything that lasts does so by repeating. Energy never disappears, it only changes form. In that endless transformation, there is an underlying rhythm that feels less like a march and more like a pulse. Maybe eternity isn't a long line that stretches into infinity, but a single heartbeat repeating forever. Not moving forward or backward, but simply continuing. The philosopher Friedrich Nietzsche once described a haunting thought experiment. He asked, "What if time truly is circular, and every moment you live will return to you again and again? The same joys, the same mistakes, the same quiet nights. Would that knowledge crush you, or would it set you free? Could you love your life enough to live it endlessly?" It's a difficult question, but also a beautiful one, because it reminds us that even within the idea of repetition, there's choice. If the universe endlessly renews itself, perhaps the point isn't to escape the cycle, but to meet it with acceptance, to make peace with the rhythm rather than trying to outrun it. In a strange way, physics may agree. Some cosmologists describe reality not as a sequence of moments, but as a tapestry where all events coexist. The past, present, and future are all woven into the same fabric, visible from different angles but equally real. What we experience as the passage of time might simply be our consciousness moving along that fabric, like a hand tracing a path through a quilt that was always whole. If that's true, then nothing is ever lost, not the first dawn, not the last sunset. Every instant, every life, every flicker of light that ever was still exists somewhere in that vast continuum. Time does not destroy, it preserves, endlessly rearranging itself. And so perhaps the universe's final silence is not the end of time, but the moment when time turns inward, when the arrow bends back and begins again. The cosmic breath that once exhaled galaxies may one day inhale them again, only to exhale once more in some distant, unknowable dawn. Even our daily lives echo this deeper pattern. The heart beats, the lungs rise and fall, the tides come and go, we sleep and wake, we begin and end, each moment folding gently into the next. Life is not a straight path, it's a rhythm. The pulse that began in the stars continues in us. When you breathe, you're taking part in the same ancient motion that expands and contracts the cosmos. There's a quiet peace in this idea. If time is circular, then nothing is truly gone. Not the people you've loved, not the moments you've cherished. They simply move along another curve of the same circle, waiting to be met again. Perhaps that's what eternity really is. Not endless length, but endless renewal. The feeling that even if everything fades, it will someday return in a different form. The understanding that what we call the end is just a doorway back to the beginning. And maybe this is why the idea of cycles feels so natural to us. The seasons, the moon, the flow of breath. All of them remind us that endings are never final. They're invitations to rest, to begin again. To remember that the universe, like us, lives by repetition. So as we follow the thread of this thought a little further, our exploration begins to turn inward, away from the stars and into the mind that perceives them. Because if time bends and eternity renews itself, then perhaps time isn't something that exists outside of us at all. Maybe it lives within us, in the act of noticing, in the spark of awareness that divides one moment from another. And if awareness ever fades, what happens to time then? If you close your eyes and listen closely to the world around you, time seems easy to find. It's in the ticking of a clock, the hum of a refrigerator, the rhythm of your breathing. It's the steady pulse that separates one moment from the next. But if you listen longer, you begin to notice something strange. Beneath all that motion there is silence. Between one heartbeat and the next, between one thought and another, there's a pause so small it almost disappears. That pause is where time hesitates. Physicist Carlo Rovelli once suggested that time may not be a fundamental thing at all. It might not flow like a river running endlessly forward, but emerge instead from change, from the way one state transforms into another. In that sense, time is not something that exists everywhere, but something that appears only where something moves, decays, grows, or thinks. If nothing changes, time itself ceases to have meaning. It doesn't stop with a bang or a clock's silence. It simply forgets to exist. This idea can be unsettling at first. We've built our entire understanding of reality on the assumption that time is always there, ticking, flowing, measuring. We wake by it, eat by it, age by it. But imagine a universe with no motion, no heat, no decay, no thought. A world in perfect stillness. What would it mean to say that a second passes there? Without difference, a second and a century would feel the same. And perhaps that's what happens at the end of everything. Not that time ends, but that it becomes irrelevant. Like a story that has already been told and no longer needs new words. When the universe reaches that state of perfect stillness, the concept of before and after loses its purpose. The clock is still on the wall, but its hands no longer move. It's tempting to think of this as an ending, but maybe it's not. Maybe it's something more like a pause, a breath held by the cosmos, waiting to exhale again. Because if time depends on change, then the smallest fluctuation, the tiniest shift, could awaken it once more. The faint vibration of a particle, the whisper of energy where there should be none. That would be enough to stir the silence, to give time its rhythm again. Even in our own lives, we can feel hints of this truth. Think of those moments when time seems to stop, when you're watching a sunset or hearing a piece of music that feels eternal. For a heartbeat, you're suspended, outside of clocks and minutes. The world is still, yet somehow more alive than ever. Those moments feel like fragments of timelessness, the places where awareness meets infinity. It's not that time disappears, it simply loses its usual shape. What remains is pure presence, the sense of being part of something continuous, without beginning or end. In that state, the division between past, present and future softens. There's only this, the now, stretching wide enough to hold everything. Some philosophers have compared this to a dreamless sleep, not because it's empty, but because it's whole. In deep sleep, we are unaware of time passing. Yet we wake to find that time has moved. Where did it go? Perhaps it never moved at all, as perhaps it simply waited for awareness to return, for the observer to wake. If time is tied to awareness, then the end of awareness might also be the end of time, not in a tragic way, but in a peaceful one. Like a candle being blown out after lighting 1,000 others. The flame is gone, but its warmth lingers in the air. Awareness gives the universe its sense of movement, its sense of sequence. Without it, the cosmos may still exist, but without narration, without memory, existence without story. And yet, this raises a beautiful question. What if awareness itself is part of that cosmic cycle? What if, just as stars are born from dust and return to dust, consciousness too rises and falls within the great rhythm of time? Each thinking being, every moment of reflection, could be a spark of the universe remembering itself, a brief flare of light in which the cosmos becomes aware of its own unfolding. If that's true, then even when time forgets itself, awareness may someday return. A new universe might awaken, carrying within it the faint imprint of the old, not as memory, but as potential. Time would find its footing again, stretching out from silence into rhythm, from stillness into song. In that way, the story of time is also the story of perception. Without an observer, the universe may exist, but it does not know that it exists. Awareness is what turns existence into experience. It's what gives time texture, direction, meaning. When we measure seconds, when we recall memories or imagine the future, we're shaping time within our minds, weaving it into a pattern that feels continuous. That's why, in the deepest sense, you are not in time. You are time. Every thought, every heartbeat, every change in your body and mind is a manifestation of the same flow that moves galaxies and grows trees. You're the measure through which the universe feels its own passage. And when your thoughts slow, when your body rests, when you close your eyes at night, time itself softens with you. Perhaps that's what eternity means. Not endless duration, but the absence of duration. A place where everything is already complete. In such a state, time doesn't end. It dissolves into understanding. The universe doesn't need to move forward anymore because everything that could ever happen has already happened. And everything that could ever be known is quietly present. There's a kind of comfort in imagining that. When time forgets itself, nothing is lost. The stories we've lived, the love we've felt, the questions we've asked, all of it remains woven into the greater stillness. The universe doesn't erase, it absorbs. And when it breathes again, when awareness returns, those patterns will echo in new forms, new lives, new stars. So maybe the end of time is not a curtain falling, but a deep sleep between awakenings, the dreamless rest of a cosmos that has finished one long day and prepares for another. As our quiet journey approaches its end, we return now to where we began, to the scale of the human heartbeat, to the moments that make time feel alive again. For even if the universe one day forgets itself, here in this small corner of creation, time still flows. It still beats softly beneath your skin, reminding you that you are part of its story, a moment that matters in the endless whole. If you've made it this far, through the fire of stars, the slow cooling of galaxies, the silence of the last black holes, and even the sleep of time itself, then we've arrived together at the quiet edge of everything. But here, at this edge, something unexpected happens. The story that seemed to stretch across billions of years begins to fold gently back toward you. The vastness becomes personal again. Listen for a moment to where you are right now. The faint ticking of a clock, the hum of an appliance, the soft sound of your breathing. Maybe a car passes outside, or a floorboard creaks in the night. These sounds might seem ordinary, but they are your universe in motion. Every vibration, every heartbeat, every rustle of air is proof that time is still alive here, flowing through you. You are surrounded by what physicists would call space-time, but what you can simply call presence. The same rules that once guided galaxies still guide the rhythm of your body. Every breath you take carries traces of starlight. Every atom in your skin was once part of something immense. You're made of the same carbon that drifted out of dying suns, of oxygen once split by ancient light, of iron that burned in the hearts of supernovae. When you breathe in, you're breathing the history of the cosmos. When you breathe out, you give something back. The story of the universe has always been the story of transformation, and you are part of that cycle. A small, luminous thread in a tapestry so wide that it takes the night sky itself to display it. The molecules in your blood once floated as dust between stars. The warmth in your chest is the same kind of energy that fuels the sun. The consciousness that notices all of this is the echo of the universe remembering itself. It can be strange to realize that the end of the universe and this single fleeting moment share the same substance. One is unimaginably vast, the other small enough to hold in the palm of your hand. Yet both are built from the same pattern. Matter dancing with energy, light meeting darkness, order emerging from chaos. The same equations that describe the birth of galaxies also describe the rhythm of your heartbeat. You are, in the most literal sense, the cosmos brought to awareness. And because of that, every second you live is a kind of eternity. The future and the past converge in the present, the only place where experience truly exists. Think of the seconds that have already passed tonight, each one gone, yet somehow still alive in your memory. And the seconds still to come. They exist only as possibility, waiting for you to meet them. The present moment is the bridge between them, and on that bridge you're both traveller and landscape. Maybe that's what forever really means, not a line stretching endlessly forward, but a single instant wide enough to hold everything. The now is where all of time meets itself. It's the quiet surface of a pond that reflects both, the stars above and the stones below. You don't have to reach the end of the universe to touch eternity. You already carry it within you, in the slow ticking of your pulse, in the awareness that you are here at all. To be conscious, even for a moment, is to take part in the universe's oldest act of creation, the turning of silence into story. If you look around your room, everything you see, every object, every glint of light, is part of a chain of events that began more than 13 billion years ago. The photons hitting your eyes right now have travelled an unbroken path through time, reflecting off the things you love and finally finding you. In that sense, you are never separate from the cosmos. You're both observer and participant, the watcher and the watched. Sometimes, late at night, when the world grows quiet, you can feel this more clearly. The boundary between yourself and everything else begins to soften. The walls fade, the noise falls away, and you sense that what you call you and what you call the universe are not different stories, but the same one told from two perspectives. Maybe that's why the thought of time ending doesn't need to frighten us, because even if the stars fade and the galaxies dissolve, the essence of what we are, awareness, curiosity, love, may continue in forms we can't yet imagine. The atoms that make up your body will scatter one day, but they won't be lost. They'll drift, merge, shine, and remember. The energy that animates you will flow onward, just as it always has. In the grand scheme of the cosmos, a human life is a whisper, but whispers can travel far. Every act of kindness, every spark of understanding, ripples outward in ways we'll never fully see. Perhaps that is how the universe keeps time, not in seconds or centuries, but in the gentle continuity of compassion, in the quiet persistence of curiosity. So when you lie down tonight and close your eyes, know that you're not separate from the story we've told. You're part of the same fabric that stretched itself into galaxies, that learned how to burn as a star, that dreamed itself into awareness. The universe has spent billions of years learning how to look back at itself through you. And perhaps this is the truest answer to the question we began with. When will time end? Maybe it never does. Maybe it only pauses, changes, renews. Maybe time doesn't vanish at all. It simply closes its eyes for a while, dreaming itself into new forms. In this quiet moment, with your breath steady and the world hushed around you, eternity is here. It's not far away, not hidden in equations or galaxies, but in this single heartbeat, in the space between one thought and the next. This, right now, is the moment that lasts forever. Thank you for walking this long, luminous path tonight, from the first dawn of time to its imagined twilight, and all the way back to your own gentle pulse. If your eyes grow heavy, let them. If your thoughts drift, let them wander. The universe will keep unfolding softly around you, and in its endless, patient rhythm, you can rest, not as something small within it, but as something infinite, briefly remembering itself.